So in this problem, we are dealing with an annuity. At the end of each month for 24 months, $200 is put into an account which pays 8% annual interest, but it's compounded continuously. So we want to find the future value of this account and round to the nearest cent. Okay, so there's a small trick to it, and that's with the interest rate here. So N is the number of payment periods. So in this case, 24 is N. 200 is the amount put into the account each time, so that's P. Now the interest rate, it says R is the interest rate per time period. So if the interest rate is 8% annually, but we're depositing money each month, then we need to divide by 12 to get the monthly interest rate. So R is equal to 0.08 divided by 12, which is a repeating decimal. So I'm actually going to leave it as just 0.08 over 12. I don't really like doing that, but that's okay. So I don't want to round, so. Okay, so for the integral, to get the amount, we're going to go from 0 to the number of payment periods, that's 24. P, $200. E to the interest rate is 0.08 over 12. T dt, and that's what we're going to integrate. From here it's pretty computational, but I'll keep going anyways. So I'm going to pull the 200 out front. Then to anti-differentiate e to this, the 0.08 over 12 is the coefficient of t. So we're going to multiply by 1 over 0.08 over 12 times e to the 0.08 over 12 t. I'm going to take that from 0 to 24, but first we're going to simplify a little bit. So this is 200 times the reciprocal of 0.08 over 12 is 12 over 0.08. And I'm going to go ahead and just factor that, or not factor, but pull it outside of the parentheses. So then I'm left with e to the, this times 24, so 0.08 divided by 12 times 24. I'm going to just write it with the 24 on top, like that, with the times there, minus e to the 0. Obviously, you've got to be pretty careful about how you enter this in. So 200 times 12 out front, 2400. That's just those two numbers multiplied, divided by the 0.08. Then here, 0.08 times 24 divided by 12 is going to be 0.16. So e to the 0.16 minus e to the 0 is 1. I think you can calculate that and get your answer from here.